Okay, let me get everybody's attention here real quick. All right, excellent, excellent. Okay, so
What's up with the whole?
that it's just a thing.
Just you
We're
can't
kind of
talk
waiting on
on
the
the
order.
hands raised.
What's a high five? Nobody will.
Exactly, nobody will do it. Oh, finally.
Now we don't have to put our hands up anymore.
What I want to go through now, here's kind of if we look forward through the end of the weekend kind of thing here. I've got I actually got 3 assignments up now. The second one, I need to put a due date on it. I'll do that right away. That'll be Sunday night. Third one, let's just say, I don't know, like Monday night would be fine. The third assignment really doesn't add anything conceptually different to the second assignment. What it does is it's going to ask you to do some things based on, instead of just giving you an equation written algebraically, it's going to give you like a sentence that describes an equation. You have to interpret that in terms of algebraic stuff and then solve the equation. So it doesn't add a whole bunch. One thing though that I do want to point out that comes into play on both the second and the third assignments a little bit is this idea of what do you do when you're saddled with solving a linear equation that involves a bunch of fractions. Okay? Now, bottom line is, one thing I want you to remember is that fractions, although they may be scary looking, they're just numbers. And so the same strategies and the same techniques that we use to solve equations normally with integers will work for fractions. But there are also some ways that we can make our lives a little simpler. Now let's start off here real quick. Let's just kind of warm up with an easier problem. What if we had something like, let's say, what if we had something like this? Let's make it easier. What if we had 5x minus 2 equals 2x plus 11? Something like that. If I want to solve for x here. Now when we solve for x, we're trying to isolate x, right? But what's the problem? Why can't I isolate x yet? Say it again? X isn't by itself. I've got more than one x up there. How can I possibly isolate x if there are multiple x's in the equation, right? So I got to combine them, right? So whenever we start off, and I want to use the proper terminology, but then we'll kind of talk about this in terms of just what we do to manipulate the equations too. So whenever we start off with multiple x's in a problem, we have to simplify things. We have to crunch it down so we only have a single x, right? If you want a template or a roadmap for doing that, simplifying is normal order of operations. Right? So we could just write down our order of operations tree, always a good idea, and if we're simplifying, we're going top down like normal. Okay? In this case, we probably don't need it, it's probably overkill. There's not a lot to do here. What am I going to do when I simplify in this case? What could I do to make this equation look simpler? Say it again, I heard it. Add and subtract, and specifically, what are we adding together? Combining like terms, right? So we want to crunch the x's, compress them into a single term. Now we can do this many ways, but we want to start using good habits from the beginning of the year. We want to make our lives as easy as possible. So even though it'll work both ways, is there a slight preference? Do we want to gather the x's in this case on the left or the right? The left is probably better. You're right. Why is that? Why in this case we want to gather the x's on the left?
5 is greater than 2.
5 is greater than 2. Sure. We want to if we want to push the x's to the side where we have more to begin with, so that we have a positive number of x's, a positive coefficient of x. Just a slight hint. It's going to work either way, but there's potential to make mistakes if you don't take the easiest path. So we will subtract 2x from both sides, because that's how I'm going to push the x's to the left, isn't it? Right? I've got to get rid of that positive 2x, so I'll subtract 2x. And what that does then, it's nice to talk about this visually. That literally pushes the x's to the left part of the equation. These cancel, and on this side I'm left with a 3x, right? And here's my equal sign, which stays in the same place. Now, as long as I'm pushing the x's to the left, and I'm thinking ahead here, I'm going to be isolating x, I might as well at the same time do what else? if I'm trying to isolate the x's on the left, what does that mean I need to do with all the other constants? Push them to the right. I want to push them away from the x's, don't I? Right? So how would I accomplish that? Add 2. I want to get rid of that negative 2, so I'll add 2 to both of the constants. Those cancel, and I'm left with 11 plus 2 is 13, right? Now, one last step. What do I do to get the x by itself? Divide by 3. Divide both sides by 3, and so the 3's cancel, and I end up with the answer x equals, whoops, not 13/13ths, 13 thirds. Okay? Is it a problem that we get a fraction in our answer? No. We didn't get it till the last step, right? We didn't have to really deal with a bunch of fractions there. That's no big deal. Once we can get it to look like this, well, if we have a problem like this, it's really not a big deal. We have integers, they combine easily. The algebra is very simple to do. Okay, not so much here. You got all these darn fractions. But the same techniques still apply, right? So now I've got 1/2 x minus 5 thirds equals 1/4 x plus 19 fourths. Just like before, we're going to want to push the x's one way or the other. Which way do we want to push them this time? What's bigger, 1/2 or 1/4? I'm seeing a lot of people pointing this way. Yeah, 1/2 is, isn't it? 1/2 is a bigger fraction. So we want to push the x's to the left, again, just like last time. So we'll subtract 1/4 x from both sides. That's good. It gets rid of the x's from the right side. And while I'm at it, what might I do with the other constant fractions? Send them the other way. Good. So we could add 5 thirds to both sides, and that'll cancel those. That's good. So what do we end up with then? On the left side, we've got 1/2 x minus 1/4 x. On the right side, we've got 19 fourths plus 5 thirds. Right? Okay, that's a lot of fractional stuff to do. Now, one little hint also that might be helpful to you here. Whenever you've got fractional coefficients, and when I say a coefficient, remember what that means.
Hi. One of these is for Brittany McDowell, and the other one is for Shelby.
Okay, where did I, there's Brittany, and where's Shelby?
She's not in this class.
Oh, okay, I'll give that one back.
Yeah.
There's Brittany.
Do you know what class she's in?
Thank you. Yeah, I might check it out, not sure. Okay, so, going back to our last example, like when we talk about coefficients, what's the coefficient in the term 5x? What's the coefficient? 5 is, right? All a coefficient means, let me write that word down. This is one you'll see a lot. A coefficient is just a constant that's multiplied by a variable. So 5, because the 5 is being multiplied by the x, we'd say 5 is the coefficient of x, right? So in this problem here, what's the coefficient in this first term? 1/2, because 1/2 is being multiplied by x, right? So when we have a fractional coefficient, what you can always do, fractional coefficient, you can move the variable into the numerator, and that's often helpful to do. So in this case, rather than thinking of this as 1/2 times x, I can just push the x into the numerator and rewrite that as x over 2. Because after all, it's really just 1 over 2 times x over 1. If I multiply straight across, I get x in the top, right? So x over 2 minus x over 4. Okay, so let's deal with the left side then. How do I subtract or add fractions? What do I always have to do?
Find the common denominator.
Yeah, I need a common denominator, don't I? Okay, I gotta find, now let's think of what that means. Common denominator, remember, is the smallest number that the denominators both divide into. In other words, it's the least common multiple of the denominators. So what in this case is the smallest number that 2 and 4 would both divide into? 4. 4, right? Now 2 won't work because 2 is too small. 4 doesn't divide into 2, but 2 does divide into 4, right? So in this case, 4 is the common denominator. We already have a 4 in the denominator of this fraction, but the first fraction, we need to get a 4 on the bottom. What do I need to multiply the denominator by to make it a 4? 2. Now I gotta do the same thing with the numerator though. So I've gotta multiply top and bottom by 2. And that's gonna give me, in this case over here, I'm gonna get 2x. I multiply straight across when I multiply fractions. Multiplying fractions is actually the easiest thing you can do. Fractions. So I get 2x over 4 minus x over 4. And once I have a common denominator, how do I do that? What is 2x over 4 minus 1x over 4? X over 4. The common denominator just stays put, and we just subtract the numerators, or add in the case of addition, right? So this just becomes x over 4. Now what about the other side? Let's look over here. On the other side, we've got 19/4 plus 5/3. What's my common denominator going to be for the right side of the equation? We agree, 12? Does that make sense? That's the smallest number that both 4 and 3 go into. The product of the two numbers will always work, won't it? Even in this last case, 2 times 4 is 8. Well, that would have worked, but it just would have made the numbers bigger than they needed to be, right? We'd rather make them as small as possible. So what can I multiply this fraction by to get a 12 on the bottom? 3 over 3, right? This one. Okay, and if I do that, then if I multiply straight across, I'm going to get 57/12 plus 20/12 is how many 12s? Lots, yeah. 77? So this is equal to 77/12. And what's my last step? Multiply by 4. Multiply both sides by 4. Good, so. Okay, so those cancel. I get x equals. Now there is one other little trick here. It's important to consider when I'm multiplying fractions like this. You multiply straight across. 77 times 4. That's a big number, right? 308, big number. We don't want to deal with these huge numbers if we can avoid it. If I multiply straight across and get 308 over 12, it's hard to reduce. Is there a better way? Yeah, good. I'm seeing lots of people doing this kind of thing. We're going to cross-reduce, aren't we? We can do that, or cross-cancel. You can only do that, though, and listen very carefully to this statement, because this is a biggie. You can only cross-cancel or cross-reduce for multiplication. You cannot do it for addition or subtraction. Yes, ma'am? Yes, ma'am. Okay, so if we cross-cancel here, 77 over 12 isn't going to reduce, but 4 over 12 does reduce. What's the number that divides into both 4 and 12? 4 does, right? 4 goes into 4 once, goes into 12 3 times. That makes it a lot easier. Now when I multiply straight across, I just get 77 over 3. Wow, a lot of stuff. That's a lot of work, isn't it? I mean, it's not, none of it's really super hard work, but that's a lot of stuff to do to get that problem. Would you like a much easier way to do that? I would, right? There is. A much easier way. Watch this. This is one of the greatest tricks, one of the greatest, best kept secrets in math and algebra. This is a great one. Watch what you can do here. There's a trick. When you are adding up a bunch of fractions, adding or subtracting fractions, you can clear the fractions out of the problem by just multiplying both sides through by the least common denominator of all the fractions on both sides. So let's break that down into a process here. What does that mean? So if I look at the denominators, there are only 3 different numbers that appear in the denominators, right? 2, 3, and 4, and I see the 4 twice, but that doesn't matter. The 4 appears, that's the other number. So what is the least common denominator of all those denominators? The smallest number that 2 and 3 and 4 all divide evenly into. Everybody agree it's 12? So if I multiply both sides through by 12, watch what happens. This is like magic. Multiplying by 12, that's the same thing as 12 over 1, right? So if I distribute that through, now watch the magic. 12 over 1 times 1/2 x. Well, that's going to become, I'll just write it like this first, minus 12 over 1 times negative 5/3. Equals, if I distribute it over here, I get 12 over 1 times 1/4 x plus 12 over 1 times 19/4. That still looks pretty ugly, but watch this. When I multiply these across, I can always cross-cancel, and the denominators will always disappear. 12 over 2 reduces to 6 6 over 1. That's good. We love having 1s in the denominator because any number divided by 1 is just itself. You don't even need the 1s in the denominator, right? 12 over 3 reduces to 4 over 1. 12 over 4, 3 over 1. And once again, 12 over 4 is 3 over 1, right? And now when I multiply straight across, I just get 1s in the denominators of all those fractions. So I get 6 times 1x over 1 is just 6x. 4 times 5 is 20 over 1. 3 times 1x is 3x over 1, and then 3 times 19 is 57 over 1. So that's easy. We can do that one now, right? Gather the x's on one side, push the constants the other way, and then just divide both sides by whatever the coefficient of x is. Yeah, I'll leave that up to you. That's pretty good. Compare those two. Look, we got this ugliness compared to this, that's relatively a lot easier, isn't it? But we can even do better. We can do this same process. Now, I want to show you how you can abbreviate this whole process when you're clearing fractions. And you can do it much more simply even than this. You didn't think it was possible, I'm sure, but it is. Watch this. If we distribute our 12 over 1 all the way through, you have to watch this closely. I can't really write all this down. You kind of almost have to talk your way through it. But watch what happens. When I multiply 12 over 1 times 1/2 x, I can reduce first, always. What is 12 divided by 2? 6. I multiply that times the numerator. How about that? Isn't that great? So then I just get 6x. 12 over 3 is 4 times the numerator. 4 times 5. Isn't that great? 12 over 4, 3. Cover those up, that just becomes a 3 times 1, right? And then 12 over 4 is 3 again, times 19, 57. How easy is that?
Magician.
Isn't that great? Yeah.
So easy it came in.
Exactly. Okay, I think we're good. Let's head down to 205.